everyone. Thank you for joining us today. Our event on accurate drone mapping without GCPs will commence now. In conjunction with Wingtra, we are very pleased to introduce you to Mr. Thomas Barucci, who's a photogrammetry expert here at SimActive. And I'm also very pleased to have Miss Andrea Nater, who's the Customer Success Manager in Geomatics at Wingtra. They will be leading the event today. And towards the end, we'll also have a little while for any question that you may have. Please do use the question and answer section in your browser, and we'll answer your questions at the end of the event. Thomas, if you're there, over to you.
Yes, sir. So hello, everyone. Hope you're doing very well today. Thank you, Vivian, for this nice introduction. So welcome to the SimActive online training session. My name is Thomas Barucci, and I'm the photogrammetry workflow specialist here at SimActive for our European branch. And I'm very happy to be your host today for this highly interesting session about how to perform high accuracy drone mapping without GCPs. So no ground control points. What are you going to learn today in the session? So first, Andrea will talk about how to correctly plan a mission with a Wingtra drone. She will then explain how to collect the optimal drone imagery and how to post-process the data to get the best results possible. I will then discuss how to perform aerial triangulation with the PPK data in our Correlator 3D software, which is probably the most important step, the aerial triangulation in the photogrammetry processing, and you'll understand why in a few minutes. Then I will talk about how to generate DSM, a DTM, and an orthomosaic with the software. And once the processing has been completed, we will then see how to assess the final project accuracy. And after, we will discuss also how you can optimize and improve your processing workflow. And at the end of the session, as Vivian mentioned, we will try to answer a few questions you may have, Andrea and myself. And if I have enough time at the end of the presentation, I will try to give you a few tips to optimize and improve your processing workflow. So I think Andrea can now start her presentation.
Yes. Hi, everyone. Also from my side, I'm very happy to share some insights on how to get the best data acquisition. I'm sharing my screen. I hope you can all see it. Yes, perfect.
Yes, we can.
Perfect. Yes, I will give a short introduction about Wingtra, our company, and also the drone. And then I'll focus on how you best plan your mission and how do you do the best data acquisition to enable accurate outputs. So let's jump in. So Wingtra, we produce and manufacture a professional surveying drone, the Wingtra 1. It's it's capable of mapping very large area in an efficient manner. And the big advantage also is that it can take off and land from everywhere. Our customers are from different applications, or the drone is used for different applications. So for one big part is surveying and GIS, and also mining and aggregates. And the drone is also used for construction and infrastructure and agriculture and environmental applications. We have a quite range of customers, so from mining companies that have their own Wingtra 1 to engineering companies such as Tetra Tech or Cornerstone, or also utility companies as the Swiss Railway Company, and also American Electric Power as an example. Besides companies, we also have, the drone is also used a lot in research and also from NGOs, as an example from the ETH Zurich or the Red Cross. As you can see here, here's some impressions from the field from different customers. So the drone is used to map glaciers or mountains in the deserts. And our customers, they really enjoy mapping with the Wingtra One, and we are always very happy to see when they send us a picture or also post some pictures on social media showing them with the Wingtra One. Yeah, so why are customers happy about using Wingtra One? So the main reasons are you can map really everywhere, you can cover large areas at a high resolution, and you get the most accurate and reliable outputs. Now I want to show you some examples for all these 3 points. So what does it mean that you can map everywhere? So the drone is a VTOL drone, which means it takes off vertically and lands vertically. So you can take off from confined areas, such as from a boat or from forest lanes. Due to the landing also vertically, you can land really softly, and this allows you to take off from rocky grounds, such in open pit mines. So you don't need to look for large areas of grass. Because the drone lands on its tail, the sensors, which are nicely integrated into the drone's body, they don't get in touch with the ground. So that's also very nice. And due to the vertical landing, you can pause at any time the flight and also adjust the position of the landing if it's required. So you, as I said, you can cover large areas because the camera is well protected, and also due to the flight behavior of the drone, we are able to have a really high resolution camera in the drone. So the 42 megapixel camera, which we have integrated, it's a little bit heavier than standard 20 megapixel cameras, but this really makes the difference. So you can fly at higher altitude, but still get very low GSD, so a high resolution. And due to this, you can cover larger areas than with other drones, for example. Due to the change to the fixed wing modes, so after the start, you change to the forward flight, and due to this, you can cover large areas very efficiently, and you get a flight time of up to 59 minutes. Besides the camera, to get high, accurate, and reliable outputs, you also need a high quality GPS receiver. So we have integrated a dual frequency PPK antenna from Septentrio, which makes it really a unique combination where you can get absolute accuracy down to a centimeter level. More on how to achieve this will follow. Yeah, so besides the RX1, we have also different cameras. Just shortly to give you an overview, there's the 42 megapixel camera, which gives you the best resolution. And we also have a 20 megapixel camera that has a little bit of shorter focal length, which enables you, if you have a fixed flight height or a limited flight height you need to obey, you can get the most coverage out of it due to the larger field of view. Besides the RGB cameras, we also have specialty cameras. These are the two cameras from MicaSense, so the Red Edge MX, with 5 bands, and the Altum camera with also 5 multispectral bands and an additional thermal band. So let's jump into flight planning. The Wingtra One comes with a tablet where the flight planning app Wingtra Pilot is already pre-installed. The app is really designed to be as safe as possible and also as easy to use as possible. I'll hear some details on how it actually works. So you need to draw your area which you want to map. You can do this either by drawing the area, by dragging and dropping the points, or you can import your KML file with the area of interest. And you define the GSD. So this is very important if you want to achieve a certain accuracy. So the horizontal accuracy you want to achieve can be maximum the GSD. So 1 GSD is approximately the horizontal accuracy, and usually 2 to 3 times the GSD is what you can expect as the vertical accuracy. And yeah, you optimize the flight lines in order to cover the area of interest as efficiently as possible. For the overlap, with the high quality RX1 camera, you can achieve good outputs, good maps down to 60% overlaps. But for some areas where you have complex structures or fast changing terrain, we recommend that you use more than 60% of overlap. Yeah, you can, as I already said, you can import your areas or your corridor as a KML file. And what is also important for the accuracy is that you have a uniform ground sampling distance so that the entire map has the same resolution. And to achieve this, you can use the terrain following functionality. So this ensures that you have also, if the terrain is changing, that you have always similar GSD in the entire area of interest. You can use the already included SRTM dataset for the elevation, or you can also, if you have a more accurate dataset available, you can use your own elevation model. Then to data acquisition. So in Wingtra Pilot, you will get a checklist which you need to fulfill before the start. And there's many automated checks. And yeah, once all these checks are green, you're sure that the system is ready and you can start the flight by pressing a button from the tablet. The flight is fully autonomous, so you don't need to interact with the drone at the start or also in the landing. So the full flight is autonomous and is safe. What you can do, you can observe the flight progress during the flight on the tablet. So you see where the drone currently is, and you also have the chance to interact with the drone if there is if you want to adjust the landing position or if you want to pause the drone in air. Yeah, in order to get the best possible images or the best possible image quality, we recommend that you fly on a bright day. So you want a lot of light, but still not too sunny. So if the sun is shining too much, or especially in the morning and evening, you get a lot of shadows, which then will be visible on the map with black areas. So a cloudy day is recommended. After the flight, you get the images and the GPS data from the drone directly on the SD card. And now you can geotag your images in Wingtra Hub. You can either use the data available on the drone to perform a non-PPK geotagging. This is very straightforward and no additional data is required. And with this process, you achieve a geolocation accuracy of few meters. And also you can use a reference station or a correction data from a reference station, which then enables you to generate the geolocation with centimeter accuracy. Now, in the following slides, I will focus on the workflow to get PPK data, to get the centimeter level accuracy, which then enables you to process your data without GCPs. Yeah, so as I said, for PPK processing, we require data from a reference station. This is, it can be a course or VRS dataset, which can be downloaded from your local course provider, or if you already have your surveying tools, you can also use your own base station. Yeah, what is important, it should log to the same at the same time as the drone is logging satellites. It needs to also log the same data. So you want also multi-frequency, so L1 and L2 frequency. You want to get the best results. You want to see as many satellites as possible. So a base station that can log GPS and GLONASS. And also for optimal accuracy, we recommend to log with an interval of 1 second. You can get results up to a logging interval of 15 seconds. So that works as well. Yeah, besides the logging of the satellites of the reference station, you also need to know where this reference station is located. If you use course data, this location is already provided from the provider. So, and in case you have your own base station, you have two options. So either you set up the base on a new point, and if you do so, this is very important that you define this location very accurately, because the data from the drone will be relative to this position. And if you want to fit your drone data into an existing survey, so if you already have some fixed points or some surveying done in this area, then we recommend to use one of the existing survey marks where you can set up your base and use the same coordinates that were previously defined. Yeah, as I said, it's good that both the drone and the base log the same and as many as possible satellites. For the drone, this is not as critical because mostly you fly above any objects. But for the base station here, be careful if you set it up not too close to any tall objects. And to get the best results, you get them if you have the base station right next to the takeoff location of the drone. So if this is the case, both drone and base can log simultaneously the exact same satellites in the same environmental conditions. So this will lead to the best results. And then as further away as you get, we can approximately say with each 10 kilometers, you lose approximately 1 centimeter of accuracy. And besides distance, also the vertical difference is relevant. So you should make sure that the base station is not more than 500 meters above your takeoff location, if possible. And if your base is further away than 100 kilometers, you cannot expect geotagging accuracy below 5 centimeters. Yeah, now we talked about how to get the drone data, and now we also want to have a look at what ground data is required or what ground data is recommended. So ground control points is always an interesting topic. So ground control points are used to scale, locate, and orient a project. So if you decide to use ground control points, it's very relevant that you have them well spread across your area of interest. And you require a minimum of 3, but recommended is rather 5 to 10, and for larger areas even more. And we really recommend to use them, or we recommend to use them for non-PPK data. So there, if you only have meter accuracy, you can tie them to the exact position on Earth with ground control points. And also for some PPK projects where you are working with a custom coordinate system, which might have been set up before and where you don't have a conversion or transformation from your to this custom coordinate system. So if this conversion is not available, then we also recommend to use some ground control points, which then enables you to fit the drone data in your existing survey. Checkpoints on the other side are points on the ground that are not taken into account during processing. So they really provide you an unbiased accuracy estimation. So as they're not included in the processing, only a few points are required and the distribution is not as relevant. And yeah, so important is to know that even for projects when you use ground control points or for Wingtra and PPK where you don't need to use ground control points, we recommend to use few checkpoints, which allows you to get an accuracy estimation. We recommend this due to the fact that it enables you really to detect any mistakes during processing. So you can see if it's off and you can correct it. And also when providing the data to a client, you actually have a proof of accuracy. Yes, so what is the big advantage when you have accurate drone data where you don't need ground control points? So first of all, you save a lot of time. So having less points to measure in the field, you save time in the field, and also you save time by clicking the ground control points on the images in the office afterwards. Furthermore, you don't rely on few ground points. So with Wingtra PPK, you have each camera position works as a control point, which is accurately defined. And whereas the distribution of ground control points is relevant and might not always be possible to distribute them well due to areas which are not accessible. So with PPK, you have accurate position at each camera position, and they are well distributed across the area of interest. Furthermore, you benefit from high redundancy. So you have, per image, you have hundreds of measurements that are used in the bundle block adjustment. So when calibrating the images initially, you have an inaccuracy of the geotags, but due to this huge redundancy, this accuracy can be improved. So the average or the errors is averaged out and the image locations become very accurate due to the photogrammetry processing. And also after the calibration, when actually generating the outputs, you also profit from redundancy as each 3D point is defined by measurements from different images from different angles. So that in the end, due to the combination of high accurate GPS data of the drone plus good image quality, you can generate really accurate drone maps that have a lot of advantage compared to single terrestrial measurements on the ground. If you want to learn more about the Wingtra 1 and also have a look at our tests where we flew the drone on very accurate ground or checkpoints, check out our homepage and also a white paper about our accuracy tests. Now I give the word back to Thomas, and he will show you how this data can then be best be processed in SimActive.
Okay, thank you, Andrea, for this very nice presentation. Let me switch this back to presentation mode. So yeah, thank you, Andrea. I will now talk about how to process this Wingtra data in Correlator 3D. So how to perform the high accuracy drone mapping without the use of GCPs. So let's start right away. So the optimal workflow for processing PPK UAV data in Correlator 3D is actually quite simple. Once your project has been created, you will have to extract the tie points between your images. The software will try to find common features between all your images to build a big block of image in order to have one block, and then to be able to match those images to generate some elevation data and generate some ortho photos as well. So if you want to assess the accuracy of your aerial triangulation, as Andrea was mentioning, you will need checkpoints. So you will have to tag your checkpoints in your project and then do your bundle adjustment, which will refine the parameters of your camera and also the angle of your IMU, such as the omega phi kappa of your camera system. Once you have a good solution for your aerial triangulation, you'll be able to extract a surface model in a raster format or in a point cloud, depending on your needs. And you want to be sure that you have the best possible results for the aerial triangulation, because all the other outputs, such as the surface model or the MOSAIC, will depend on the quality of the aerial triangulation. So once you have generated the surface model, the DSM Correlator 3D will also be able to generate a terrain model. And you can also, if you want, edit your surface model or your terrain model to refine your results. I will show you that in the software in a few minutes. Once your elevation data is good, DSM DTM, regarding your needs, you'll be able to perform the ortho rectification of all the images of your flight, and then generate a seamless mosaic with all the ortho photos at the end. And the mosaic will be seamless and color balanced. You will also be able to edit this mosaic or to play with the radiometric values of the mosaic. And you can also play with the seam lines of the mosaic if you want to refine the visual aspect of the mosaic. So how to perform aerial triangulation with PPK data in Correlator 3D? We have different modes to process UAV data, but for PPK data, the most important thing is when you import your images in the software, So when you create your project, you have to be aware that the position that you import for each image, so each exterior orientation for the image needs to be post-processed in order to have a high accuracy data. So as Andrea was mentioning, if you take the raw geotags from the Wingtra imagery and do not post-process it, you won't benefit from the PPK accuracy. So be sure that if you wanna process drone imagery without the use of GCPs, be sure that you have post-processed your geotags prior to start the processing in the software. So the exterior orientation that you will import will be the one that you have post-processed. You will be able to play with the calibration of your sensor in order to eliminate all the radial distortion of the camera. If you want to assess the accuracy of your aerial triangulation, then you will probably need some checkpoints. These are two different types of ground references. There is what we call the ground control point, the GCPs, which is traditionally used in survey, and it consists of tagging points in your image with very precise coordinates. And then you will use them as a reference to adjust your block of image during the bundle adjustment. And the other one, the one we suggest to use for PPK processing, is called checkpoints. So the checkpoints are there not to calibrate your bundle adjustment, but they are here to validate the accuracy of your bundle adjustment. So they are not used during the calibration of the bundle, but they will give you values to assess the final accuracy of your aerial triangulation. And also, I will talk a bit about interpreting the quality report specifically with the Wingtra project. So let's jump into the software and see how this works. So right now, what you see is the graphical user interface from Correlator 3D, which allows the user to produce results in two different ways. We have first what we call the one-click button solution, which is here. It's called the automated workflow. So that's for users that are not very familiar with photogrammetry processing, and then it allows you to generate in a one-click solution all the steps that are required in order to generate all the results you need. It will go, so if we open this module, it will go from the aerial triangulation to the DSM DTM extraction and the orthorectification and the mosaic creation. You can adjust a few parameters manually, or you can pick a profile here that are predefined. If you want to learn a bit more about the automated workflow, I suggest you to take a look at the webinar we did on this particular subject in our learning section from our website at simactive.com. The other way to process a project in Correlator 3D is to go step by step. So here on the top bar of the GUI of the graphical user interface, you have all the different modules in a sequential order. So if you go manually, what you want to do is you want to really focus on the results of your aerial triangulation, for instance. And by going step by step, you'll be able to, like, after each module, each step, you'll be able to check, to do your quality control. So it's really important to do this type of control if you want to generate high quality data. So one thing you generally do is, once you have completed the aerial triangulation, which is this first module, and as I was mentioning, it's probably the most important module of the whole processing. You will access the quality report, which is here. Actually, I have the PDF already opened. So once you have performed the aerial triangulation, and if you have used checkpoints, then you will see in the quality report the average XY error of the checkpoints, which in my case is 1.3 centimeters, and it's 2.2 centimeters on the Z direction. You also see the average number of tie points per image, which is very high here. So because the front and side overlap of the image is very consistent, we can detect lots of common features between adjacent images. We also see the projection system that has been used here. So we're using a UTM coordinate system. And then you also see the average projection error in pixels for the checkpoints. If you scroll down, I will talk about this direct georeferencing a bit later on. Maybe let me switch back to the software. When you start the aerial triangulation, the first step is to extract the tie points. So all the links you see here between the images. If I right click one of these links, you'll see that the software has found lots of common features, even on like a homogeneous surface here. Because the sensor is a very good sensor, we see lots of details in the imagery, which allows the software to find lots of common features and to attach all the images together. And then once you have extracted the tie points, then you can import your checkpoints and then tag the checkpoints. So as I was mentioning, the checkpoints are not used for the processing. They will be just used to assess the quality of the results, which could be an important step for the client to check the accuracy of the results. And once you have tagged your your checkpoints, then you can run the bundle adjustment and use a direct georeferencing, which means you don't want the software to play with the XYZ direction of the center of the image. So these values are constrained. What the software can only do is play with the angles, so the omega phi kappa values of the image. And you can leave the sensor calibration to unconstrained, so it will give the freedom to the software to slightly adjust maybe the focal length or the pixel pitch, the pixel size of the image. And then you want to use your ground control point as ground reference. So in this case, it will be only checkpoints, so they won't affect the bundle adjustment. And then if we go back into the quality report, we see that the EO adjustments have been set to direct georeferencing. So we see that the XYZ values are fixed. They didn't move at all. And then we have constrained the omega phi kappa angles by 60, 60, and 180 degrees. So in this figure, what we see is the image before the bundle adjustment. So you only see red dots, which means the aerial triangulation hasn't been completed yet. And then you will see after the type 1 residual error. We use a color ramp, so everything in green is considered as excellent, like the best you could have. And then the few yellow dots are imaged with a tie point residual of between 0.75 to 1.5 pixels, which is still considered as very good. But in case you want to get the very best results, you could look very locally in these areas to try to refine the tie points maybe. But still, you see that with such a good aerial triangulation results, we were able to get accuracy of 1.3 centimeters without moving the XYZ direction of the image at all. We see that we have played with the omega phi angles by an average of 1.1 degrees for the omega, 1.8 degrees for the phi, and then 0.9 degrees for the kappa. Here you will see the sensor calibration. So you have access to the different values that have been adjusted for the sensor calibration, which is also could be also interesting if you want to do like some research or testing. And then also you have the control point analysis. So if you wanna investigate deeper the details about the checkpoints, you have like all the different projection errors and spatial errors here. And also, if you want to check every checkpoints like one by one, you also have the detailed error of the 9 checkpoints we have used here for our project. So let me go back now. Oh, and then yeah, the final part is just like some information about your system, the computer you're using for the processing. Okay, so once you are satisfied with your bundle adjustment, you'll be able to extract a precise surface model and also a terrain model. So if you want to generate a surface model in Creator 3D, well, we work with a raster format. So our first output will be a surface elevation data that will be extracted in a raster geotiff format. And if you want, you could also generate a point cloud at the same time. By default, Correlator 3D suggests you generate your output at 5 times the ground sampling distance for the surface model, which is what we call our optimal resolution. So let's say if you have a GSD of 1 centimeter, well, the optimal resolution will be 5 centimeters. However, with such data like the Wingtra data, you could probably lower it, lower the resolution a bit more and go maybe to 3 times the ground sampling distance, so 3 centimeters, and add like sharpness in your output and really have the best quality data possible. If you go lower than 3 times the GSD, such as like a pixel value, like a 1-to-1 matching, so 1 centimeter in this case, you will maybe add a bit more noise to your surface. So we don't really suggest going below 3 times the GSD of your image. One thing that you really need to be aware is that the resolution of your DSM will have a big impact on your processing time. So you really need to ask yourself before starting your project, what is the resolution I need for my project? Do I really need something at a very high resolution, or should I go maybe with a lower resolution or an optimal 5 times the GSD resolution? So it really depends on your needs. So this is a question that you probably need to ask yourself before starting your processing, because it will greatly impact the timings. So from this surface model, you'll be able to extract a digital terrain model. So Correlator 3D has an automatic tool to extract a digital terrain model from your DSM. Which actually look for elevation changes and try to identify elements that are not relative to the ground, such as trees, houses, buildings, cars, and stuff like that. So that's what the algorithm does. And also, if you want to have more control on your results, you could do some post-processing on your terrain data or surface data to obtain better results. So if we go back in the software, let me just exit the aerial triangulation and then show you. Here, if I show you the DSM, let me uncheck the image in the GCPs. Well, basically, this is a very flat terrain surface with a building here and a few trees. And if we look at the DTM that has been extracted from this DSM, then you will see that the building have disappeared and the trees also have been removed. So if you want to edit your result, well, you could use our DM editing module, which is here. So you could draw some polygons over some elements. I'm going to do this over the DSM to show better. So I don't know if you want to, let's say, delete this building, you could draw a polygon around this and then use one of our tools here, such as the delete and fill, which will simply just delete the object from the DSM. You could also draw polygon and use them as an exclusion zone, which will tell the software not to generate a DTM out of certain section. So if you want to keep, I don't know if you have a stockpile maybe, and you don't want the algorithm to smooth out the topography over the stockpile, you might want to draw a polygon around the stockpile and use this as an exclusion zone when you generate the DTM. You have the option to use an exclusion zone here that you can either import as a vector file or you can draw manually yourself. Now, once you have generated your surface model and your terrain model, well, you'll be able to generate the mosaic from the individual orthos. So the first step will be to generate ortho photos together by generating by using the ortho rectification module. You can either ortho rectify over your surface model, your DSM, or over your terrain model, depending on your need. So you'll either have a true ortho if you ortho rectify over the surface, or a classic ortho if you ortho rectify over the terrain model. If you have one or two images that are problematic, like if you had troubles with your lighting conditions, for instance, at some points of the flight, you can select only a few specific images if you want to generate a subpart of your orthos. And you can also color balance your mosaic with your selected orthos. So this is all like editable manually. If you want to know more about how to generate accurate ortho and mosaic with Creator 3D, we have a 1-hour webinar on this topic that's available on our website. So if we go back into the software and look at the orthos, the software generates each individual orthos. They are just stacked on top of each other. They are not color balanced yet. So they are just like single ortho photos that have been the deformation caused by the terrain and the camera distortion are all removed. So these are the ortho photos you want to use for your mosaic. In this project, I decided to use a terrain data instead of a surface data. So the way you do this is you first select the model you want to use to ortho rectify. So once the model has been selected, if you enter the ortho rectification module here, you will have the option to either use a DSM based or a DTM based. So in my case, I want to leave this box unchecked because I'm using a terrain model. When you use a terrain model, it usually gives better visual results compared to a true ortho. So that's the reason for this project. I decided to use the terrain model. So from those individual orthos, you'll be able to create a seamless mosaic with color balancing, and also you'll be able to only, if you go into the mosaic module here, you'll be able to only use the more nadir part of the imagery if it's something you wanna use. So basically, you just like avoid using the distorted part of the image and maybe on the corners. You will focus on the nadir the nadir part of the image. And we also have a nice algorithm here, which is called the simline obstacle avoidance. So basically, if you have, I don't know, an urban area with lots of buildings and you want to avoid having your sim lines crossing the buildings, you can load the DSM and then use the obstacle avoidance algorithm. So the software will try to go away from to put the sim lines away from the buildings. Now the mosaic editing module. So if we look at the mosaic now instead of the orthos, we see that we have a nice color balanced mosaic. It's seamless, but you also have the option to edit this mosaic if you enter the mosaic edition module here. and then you select your block, you'll be able to edit the sim lines of your project, for instance. We see that the let's wait for the sim lines to load quickly. So we see that the sim lines are the lines that were used between adjacent images to generate a seamless mosaic. So you can click a sim line, and then you can edit all the vertexes of the sim lines, so you can improve and refine your results. Another thing you could do, back into the presentation. So now, finally, once your mosaic has been generated, and if you want to assess your mosaic accuracy, well, you can validate first the results with the checkpoints. So if you simply zoom in, you load the checkpoints with your mosaic, and then you zoom in. Let's wait until the viewer refresh. Connection is slow, sorry about that. Yeah, let's wait maybe a few seconds before it refreshes. So you can validate the results if you load the if you load the checkpoints, and then look at the checkpoints. You zoom in the mosaic, and then you want to check like the visual accuracy of the results compared to the checkpoints. So here I can quickly visually assess the quality. So you can pan through your mosaic and quickly see that all the outputs that were generated are really well tied on the checkpoints of your project. And also you'll be able to assess the radiometric quality of the mosaic by looking at like, do I have uniform color over the mosaic? And if it's not the case, you can also adjust the radiometric values of your mosaic. So if you click here, you can adjust the different values. So if you play with the master band, then you can change here the input minimum and the input maximum. You can play with the gamma values, and you can also go band by band. So if you want to refine the histogram here, you can play with the different values manually, and then try to get the best radiometric quality of your results. Just one quick comment: if you do this on multispectral data, and if you're using reflectant values, for instance, you don't want to play with the radiometric values, because you will affect the reflectance values of your mosaic. So this covers all the topics of today's presentation. I'm going to quickly summarize what the unique benefits are from using Correlator 3D. First, we are very proud to offer an unmatched processing speed in the industry. There is no any particular training required. Even if for some complex project, we can offer services, processing services and training. Correlator 3D has an automated workflow solution with a one-click option, as I was mentioning at the beginning. And last but not least, there is an unlimited number of images you can process, suing a single standard PC. So finally, you have also the option to batch process with the cloud interaction and command line interface. So that's all for now. I hope this was interesting for you, and you learned a bit more about processing PPK data, Wingtra PPK data with Correlator 3D. If you have any more questions, don't hesitate, as we'll have like still a few minutes to answer the questions right now. So feel free to send us your questions now.
Thanks, Thomas and Andrea, for the presentation. I've got a couple of questions that have come up. I think this one's for Andrea. It concerns the tablet that comes with the Wingtra. Mr. Ghafoor Muhammad would like to know what operating system is on the tablet. Is it iOS or Windows or Android?
Yes, so the tablet is currently a Samsung tablet that has an Android operating system. We now also have launched a beta phase for a flight planning tool on the computer. So this will be based on Windows, where you in the future also have the possibility to plan your flights on the computer.
Fantastic. There's another one for you, Andrea. Can you adjust the ISO parameters due to different different light on the flight day?
Yes, so you can adjust ISO and also any other parameters as shutter speed or aperture. We generally recommend to set aperture and shutter speed to a fixed value, which enables good data acquisition also due to the fast speed of the flight. So you want to have a shutter speed that is rather low. But when you do that, we usually have ISO on automatic. So with the RX1 camera, it gives very good image quality in a wide range of light conditions.
And the last one I've got here, if the GNSS logging is 1 second, do you compensate for platform movement during that time, as this will be several meters depending on flying speed?
Yes, so that is correct. This is a valuable question. So it's not only relevant that the GPS module is accurate, but the other point which you mentioned here, so the synchronization between when the image is taken and the GPS, this needs to be super accurate. And yeah, so this is included in the software. So we have the exact time synchronization between the camera and the GPS.
Mm-hmm. Thomas, do you have any questions that you'd like to answer? I think, Thomas, your microphone is muted.
Yeah, there is one question about the type of imagery that can be processed. Yeah, Andrea mentioned that Wingtra can be equipped with a different type of sensors. So we do support the different type of sensors. So we support what we call UAV format, which is up to 50 megapixels. We also support medium format from 50 to 100 megapixels, and we also support large format. We support multispectral imagery, so from the MicroSense sensors, for instance. If you have some sun sensors or some reflectance calibration panels, we support this type of data as well. Thermal imagery, satellite imagery, and then also scanned films. So pretty much every type of image from the industry.
I think that was it. I've got Mr. David Green, who's mentioned that his main interest was a solution for areas lacking GCPs at the coast. They've also used Wingtra pre-PPK. Would you like to make any comments on that, Andrea? Or Thomas, sorry.
Well, if it's pre-PPK, then as Andrea was mentioning, you will fall into the meters accuracy. So you won't benefit from this very accurate type of results we were presenting today. It could work for some different types of project where the accuracy can be within a few meters. But yeah, if you want to avoid using GCPs and have accurate results, then your best option will be to benefit from the PPK capabilities of the Wingtra drone or any drone with PPK data. Unfortunately, if you use the raw pre-PPK data, then you might want to use GCPs if you want to improve the accuracy.
I've got another question for you, Andrea. This one's from Laurent Duverger. Will the Wingtra OS be available for iPads?
This is currently not planned, but yeah, we have a feedback forum where we collect inputs, and so once this gets requested a lot, this might be something for the future.
One more from Mr. Ghafoor Mohammed. So is the GPS and camera set to the same intervals to ensure geotags?
I'm not sure if I understand it correctly, but you probably mean that if the GPS measurements and the camera triggering is exactly at the same time. So this is not the case, but we have the exact timestamps of when an image is taken. And with this and the GPS measurements, we can interpolate between the GPS measurements, and we can then define the accurate position of the camera when the image was taken.
Perhaps one or two more, Thomas.
Yeah, I have one question here. Like, do we have any suggestion for the type of PC required to process drone imagery with Correlator 3D? Well, Correlator 3D has been developed to work best on standard off-the-shelf PCs. So it will profit from the GPU technology and the multi-core CPUs to accelerate the processing. We actually recently revamped all the processing to profit from multi-core CPUs and solid-state drives, SSDs, and also the OpenCL technology. So we thus suggest using maybe a multi-core CPU, an SSD drive, and a decent GPU, but there's no need to invest in a very expensive workstation.
Fantastic. One more question before we end, Thomas or Andrea, if you've got any other comments to make.
Can the software calibrate different type of sensors? Yes, of course. The software can calibrate different types of sensors. So depending on the radial lens distortion, the decentering lens distortions, for instance. So during the aerial triangulation and the bundle adjustment, if you leave the sensor calibration to unconstrained, then all these parameters will be taken into account, and the algorithm will calibrate the sensor to get the best results. And I have here, what is the name of the software used? It's Correlator 3D. You can visit our website at SimActive.com. SimActive is the name of the company, so don't hesitate.
Fantastic. Thanks very much, Thomas and Andrea, for your presentations. Everyone who's joined us, the webinar has also been recorded, and we will make the recording available to everyone in a short while. If you have any other questions for us, please do get in touch with us after the session. Also get in touch with us via our email address or our websites. I've put that all in the chat, and look forward to hearing from you and having you attend the next event. Thanks very much, and have a lovely day. Bye-bye.
Thank you.
Thanks a lot for having me, and have a good day.
Bye-bye.
Thank you, Andrea. Bye-bye.